promise I will teach. What
Sir, actually, I forgot. Sir, I can't
anybody?
hear you. How the Google will use the Python in searching its.
Yes, one is yes, Google voice search. Another thing I mentioned, device control. Did I mention?
Yes, sir. No, sir. No, sir.
Internet of Things. I mentioned no.
Yes. Yes, sir. You mentioned it.
Because I haven't even showed how to control the lights in my room, right?
Yes,
Using
sir.
voice.
Yes, by
And I
Siri.
showed you how we can do that. So that's what we will learn today. Using Python, how will we control the device? So those of you who are the newcomers, today what we are, anyway, let me quickly bring up the Python code which we tried last time. I think Ambika, do you have it ready? Or I can bring up mine.
Yes.
Yeah, can you quickly show it? What did we learn last week?
Sure, sir.
So we started from very basics. Those of you who are the newcomers today, we started with how you can print your own name, how that converts your name into a calculator. How you can type your name multiple times. Yeah, just type, bring up that print hello world. That's okay. Just type, no? Just type. Yeah, this is also fine. Yeah, just run this. Yeah, just type Aditya. Let's see what it does with Aditya's name. So as you can see, it is reversing. Those of you who are coming newly, this is simple Python code. Just go back to the Python code. Yeah. So there's a function. Don't worry about the function for now. We will teach you as we go. There's a function called reverse a string. And as you can see, just a 5-line code is doing this magic. Nothing else is required. Only thing we need a Python interpreter, which is already installed. Okay. Then we also learned another interesting one, which is the swapping, right? Do you have that code ready?
Yes, sir.
Yeah, bring that up. Yeah. So we learned how the pointers work, how Brownie and Tom gets interchanged. Just run this. Yeah, first it had Brownie and Tom, it became Tom and Brownie. Without using the third variable, we were able to do it. So now let's delve directly into the next set of code. Okay, thanks, Ambika. Now I'll share my screen.
Thank you, sir.
So let me bring up. Okay, so this is, okay, let it come. Now we should be able to see. So this is my Raspberry Pi, which I have, which is running in my table. Okay, so this Python is running on my Raspberry Pi. So those of you who are new to this word called Raspberry Pi, let me show you that. I will switch on the another camera here so that I will show you the Raspberry Pi running on my table. Give me a second. Are you able to see my another screen where
Yes,
you
sir.
have to pin that?
Yes, sir.
Now we can see the Raspberry Pi which is blinking with the green light. Okay, let me move that closer to the camera. Okay, so this is the one. Let me bring up in my primary camera. Let me show you this. So here it is. So this is Raspberry Pi running. Then you can see I'm just powering this by the battery. So this is actually totally wirelessly connected to my laptop. Yeah, this is the power bank. And you can see this is wirelessly connected. Now I will show you the code, how this magic is working. Okay. Now you're able to see my code, right? So this is the code which is running on the Raspberry Pi. Are you able to see my code?
Yes, sir.
Okay. So now, again, don't worry about this first one. Import GPIO. That's a library function which I am importing. Then from time import sleep. This is a sleep function I'm importing from another library function called time. Again, don't worry. We will learn as we go. Now, GPIO stands for General Purpose Input Output Pins. Then set warnings false means now even if I start running again, then it will not give me any warning. Okay. So that's the reason why I'm telling it to false. Then set mode. I'm using the GPIO board now. I'll start controlling it. So I'm using the pin number 8. Let me bring one pen so that I can point out which is pin number 8. So this where my, let me see if you are able to see my picture. Yeah, now you see in the another camera where I'm pointing pin, you see where my pen is pointing. This is pin number 8. There are 40 pins you can see here. These 40 pins, this is actually have pin number 8. The next one is pin number 3. That is the ground. I'm just taken out 2 leads, pin number 3 and pin number 8. I have connected this to the LED which is glowing here. Now I will stop the code for a while. You can see that how this is controlling. Once I click this red button, you can see the green LED stops blinking. So now I stop the code. Now green LED is no longer blinking. Okay, now let's understand how it is working. While true. So last time in Ambika's code, you also learned while loop. It was Aditya, do you remember the while loop? Aditya or Anisha, did you remember while loop last time we did?
Yes, sir.
Yes, sir.
Okay, so now you can see the same while loop I'm using to control the light. Now, what am I doing here? So I am basically using this for output. Output means I am setting the voltage to 5 volts of pin number 8. High means I'm setting it on. I will sleep for 1 second, then I will set it low. That's how the green light starts blinking. Now let me just start it again. Now you can see the green light blinking. You're able to see it blinking right now?
Yes, sir.
So that's the magic. Now,
So their other screen is static ಅಂತ ಅನ್ಸುತ್ತೆ. I mean, is it supposed to be dynamic ಆಗಿದೆಯಾ ಅಥವಾ?
ಇಲ್ಲ, static ಅಂದ್ರೆ code screen is static, whereas you can see the light blinking, no? Green light blinking, I'm able to see.
ನನಗೆ ಕಾಣಿಸ್ತಿಲ್ಲ. Maybe others.
No, you
So we
speak.
have
ನಿಂಗ್
to pin the
ಕಾಣಿಸ್ತಿದ್ಯಾ ಅದು?
screen.
Aditya speaks only Marathi.
Okay.
Okay, you have to pin the screen. Sudarshan, pin. You pin. I am in 3 windows now. One, my video. Another is where Raspberry Pi. Basically, I have logged in 2 sessions, and third session I am sharing my screen. You pin all the 3, it is possible to see on your laptop once you pin it. To pin, what you need to do is on the middle, if you hover, the left side, a pin option comes. You can pin or unpin any window of your choice.
You can even search on in people's.
Yeah, you can search my name both. I have logged in as Kiran only.
Got it. Thank you.
So now the green light is blinking, right? You are able to see. What, Sudarshan, you are able to see the blinking green light?
Yes, sir.
Okay, now I will make it red light. Okay, this LED which I am having is a red LED. I also have yellow LED. I will show how simple it is. Let me wear my slipper so that I don't short circuit my Raspberry Pi. Now, I don't know if you are able to see it.
Sir, I
can
got
you
it now.
see?
I got it. Yeah, I got it.
In my video, can you see one lead is smaller or one lead is bigger?
Yes.
I'm showing you a lead.
The anode and
Holding.
cathode.
Anode and cathode. Do you know which one is anode, which one is cathode?
Longer lead is
Longer.
anode and the shorter lead is cathode.
Yes.
Yeah, now, yes, anode is the positive. Now
Longer.
the positive, the bigger one, the positive has to go to the supply.
Pin number 8.
Yeah, pin number 8. I'm going to do that. Now, suddenly it started, red started blinking, right?
Yes, sir.
Okay, now I will, actually it is dim. I will remove the green. You can see, no, the intensity is that much only. So how, now let me get that green again. But green is not blinking. Once I lift it, green will start. Why is that?
Sir, can you tell again what did you do?
I just put this in parallel. There are multiple ports, pins are here. I can just put this one more. I will do it again. Okay, now both LED, I will come bring it closer to the camera. You can see both are connected in parallel, right? Let me bring it closer here. You can see it clearly, no? They are parallelly connected. That means positive to positive, negative to negative.
So it should be connected in series like positive and negative, positive and negative.
Yeah, but unfortunately, our LED full form, can you tell me?
Light emitting diode.
Yeah, there is a diode. What is the property of a diode?
Positive and negative should be connected.
Yeah, means it will allow electricity to flow only in one direction. If I reverse, it will not.
Unidirectional.
Right? So
Yes.
then it will stop. So I have no choice. But here, why did green light stop as soon as I put red light?
Sir, I guess the fuse which you have, like you place the fuse, means you only placed one fuse. That's why.
No. Actually, now I will lift the red one. I'm not touching the green one, but immediately it switches to green. It's a common, basically you don't need too much of technical knowledge here. It's actually the voltage is not enough.
Sir, I thought of that before.
Yes. Actually, both are 5 volts LED. So that whatever voltage and current which my Raspberry Pi is sending is so low that it can light only one LED at a time. Okay, and then there's no other rocket science, don't worry. Then I have another LED here.
Tricolor LED.
Can you explain what is tricolor to the youngsters?
It has three colors. For example, red, green, and blue, like that.
Yeah.
In the same LED. One
Yes.
the common pin and three will be the other terminals, right?
Yeah.
For the
So-
three colors.
Yeah. What are the three colors?
Red, green, and
RGB.
blue.
Sir, RGB.
Yes, you're right. RGB.
RGB is also used in coding.
Yes. So RGB, either I can have, for example, now I have green, I have here red, then I have yellow here. So then I have an option. Now it's not even allowing me to switch between, I have to remove one and keep one. So that is not helping me. So instead I can have only one LED. Through the code I can change the color to red, green and blue. Interesting, no?
Yes, sir.
And interestingly, it is not just three color. How many colors you can generate using this LED?
All the shades of RGB.
Yeah, how many? Millions. Why do I say millions?
Because those three are primary colors.
Let me illustrate through an animation again. Okay, let me bring that interesting animation. Let me stop sharing this. Window. How many of you have used this animation Phet? Has anybody used this?
No, sir.
Somebody raise their hand, I think. Anybody? Can you
So
just
me,
unmute?
sir, at our school, they taught us to use it. They are
Yeah, yeah.
teaching us now.
Very nice. Yeah, TVS school is using it, I'm aware. Any other school? If not, please tell your teachers to use Phet animations. Okay, now light. Let me see how many light animations are there. Not bending light. Color, sorry, I should search for color. Not about light. Let me search for color. First, let me show you this magic and then we'll come to the other one. Renu, have you seen this animation?
Not yet, sir. They are teaching us now.
Yeah, now let me show single bulb. Let me bring. So what does this mean? What this animation means? Can one of you tell me?
Sir, can you tell me the bulb color? Means was the bulb red bulb?
Bulb color is yellow. Bulb is yellow. You can see yellow bulb. The bulb is here, no? I selected bulb. This is white bulb. This is yellow bulb. So even if I switch from white to yellow, there is no difference. Why? You are
Can I tell, sir?
seeing only. Yeah, go ahead.
Sir, I guess when we switch it to white bulb, as the white bulb means the white light has all the colors like Vibgyor. So if we switch it to white and the plate is like the filter color is yellow, so because when the white lights get when the white light falls on the yellow plate, it simulates the yellow light, means it takes out the yellow light from it.
Yes, you are right. Now let me change the color. Now instead of yellow, I will make gold red. Now what happened? If I change to any other color, why is it not living?
It won't go.
Why?
So because the
Because
filter
it
color is
doesn't has, yes, it doesn't has yellow in it. But if you switch it to orange, it would go because it is the shade of yellow only.
Okay. Now let it be blue. Now I will change the filter color. I will make it blue. Now if I change it to yellow, what happens?
It won't pass.
No color is passing. Only blue is passing.
Sir, violet will also pass.
Why is that?
Because it is the shade of blue. It
Yeah.
is created with blue.
But can any of you tell me why it is not allowing? What is the magic? Who said only blue color can go through blue filter? What is the science behind it? Can you ask your teacher? And tell me next week.
Sir, it is depend on filter.
I know, we saw that. But what is speciality in the filter? How does it know that only these people have gate pass to go into blue? It's as if somebody is saying, gatekeeper is there, right? If you are not blue color, I will not allow you. If it is red color, I will not allow you. If only red filter can go through red. Why is that? It's automatically happening. There is no police standing. Yeah, Anisha?
nothing, sir. I unmuted accidentally.
No, what's your guess? Why is it? Who is stopping? Because there is no magic, right? As soon as I change the color, now let me see. Now, look at it. When white color is there, I can see some color.
Yes, sir.
Yes.
Now it is allowing me some specific color depending on the color of the filter. Whereas if I'm having some specific light, then only that same light filter only allows.
Sir, because though that light doesn't has any of the color which you are changing in the filter.
Yeah, anyway, I want you to understand what the behavior. What is the difference? There is one fundamental property which anyway you will learn. And how come the same white light, when there is a rain, we see suddenly rainbow? Nobody went there to create a rainbow, right? God did not suddenly appear to create a rainbow.
Sir, can you ask the question again?
Suddenly, the white light we are seeing in the daytime, right? If it rains, suddenly we see rainbow. 7 colors. Why did we see that? Yeah, one of you answer it. Let's hear from Premdeep. Premdeep, can you answer?
Sir, the raindrops work like a prism.
It's like a prism, but what exactly happens there?
The rain will just divide the colors into.
How can it divide? Yeah. What is the magic? Can you? I'm looking for a specific.
The white light consists of 7 colors.
I know, but there is no litmus paper or any paper or a filter to separate and bend it differently. No, what happens?
Raindrops
Why does
work
light
like
bend?
prism.
Why does the light bend differently for
Sir,
different
the
color?
refraction of light happens.
Yeah. And
Can-
has anybody heard about wavelength?
Yes, I have heard.
Is the wavelength same for all the colors?
No,
Now, can you connect the dots?
sir, because of the wavelengths, the light is not passing if we change the bulb.
It's in a different way. Okay. So go and do some more additional study and come back next week, or you can share in the WhatsApp. Why is the filter of the same color leaves only that color? Similarly, why the light bends differently for different color? That's how rainbow gets generated. That's how the prism can split the colors by different. Let's also see, all those animations are covered in this Phet. Now, let me come back to the original question. Now there is a green color. Now how the RGB LED which we just saw here, which is in my hand. Okay. So how is it able to generate so many colors? Let's look at it. Now I have switched on the red light, red torch. Then we are seeing red color. What you're seeing in the bubbles on the top, ಅದು ಇಲ್ಲಿ ಯಾವ ಕಲರ್ ಇದೆ ಅದನ್ನ ಮಾತ್ರ ನೋಡ್ತಾ ಇದೀವಿ. Now I will switch off red color, switch on green color. Now I'm seeing green. If I switch on both red and green, some magic happened. What color came?
Yellow.
Because
came.
the red, green, and blue are the primary colors, so they
But
can.
blue is not there yet. Blue is not there yet. Only red and green are there. Got it?
Yes.
Now I will introduce blue. Now what color it is?
White.
Wi-Fi.
Now if I do half, what happens?
Pink.
Right? So by varying this, I can keep changing the color. Even if I keep varying one color, I keep getting different color. So like this, I can have various millions of combinations of each of these colors. I can leave somewhere in between and I can keep varying the another color. Interesting, right?
Yes.
So this is how millions of colors we can generate.
Sir,
So,
this mechanism is used in laptops too.
yes, because laptop LED is also RGB LED. Right? Laptop screen consists of millions of LEDs. You're
Yes,
aware
sir.
of that? That's why it's called
Yes.
LED screen. All the TV, color TV at home, they're all LED. There are millions of LEDs hidden in that screen.
They also have some sort of liquid called LCD and all.
LCD is a old technology. What is the full form of LCD?
Liquid crystal display.
Yeah, that's an old technology. Since it was fading over time, it was all replaced now with LED. Okay, now, yeah, it gets complicated. Now let's stick to this. So light we saw. Then if any of you are interested to learn how light is used in movies, there is a nice animation. Last time I showed you. I go there.
Khan Academy.
Let's get into Pixar. So there are nice videos. You can see it.
Fire.
You can see how they use colors, how they create sounds.
And effects creates water.
Water in the computer is really exciting and really challenging. That's partly because water takes so many forms. A placid lake you could swim in, or a rushing river not one.
And how close we are to it.
One of the tools we use to create believable water in the computer are particles.
Let's start with a single particle. We can apply forces to that particle, such as wind or gravity.
So don't worry about this. Now let's look at, there's something called color also. Let me see what all color comes. Color signs. Look at this interesting one.
What do I think color is?
What is color? I can't answer that question.
What is color? Color is a sensation.
Color is a very personal thing. Color is very subjective.
It can trigger like a visceral response. Like if you smell bacon, no, bacon. You know, it's like if you see certain kinds of colors, it's the same exact feeling.
I don't know. Ask some smart person here.
Color is a term that we use to describe a collection of attributes, hue and saturation and value that describes how we see things.
What is hue, saturation? Suddenly from color we went to hue and saturation. Any idea what they are?
Clarity of
Sir,
Yeah.
clarity.
Clarity, contrast. Anyway, each one of us
Sir,
we
it
use.
contains like colors of green, orange, yellow, and blue.
Yeah, we will see. All of them they will show now. Next 1 minute, we will just watch.
Hue is what the actual color is in the rainbow spectrum. Is it more yellow or is it more orange, bluer or redder? Value is how bright something is relative to something else. Is it white? Is it black? Is it some sort of middle gray? Saturation is how intense the color is. Is it more subdued and gray, or is it more vibrant, almost fluorescent? You know, a fully saturated color is, you know, quite eye-popping. Color is everything to artists.
It wasn't until I started working at Pixar that I think I had to think about color in a different way, you know, to apply it to a narrative and it could mean something.
Which movie is this?
Up.
Is it Aditya?
Yes, sir.
You have seen the movie?
Yes, sir. I have seen the movie.
Yeah, let's see it.
On Up, there was a scene where Carl's house got burned by months. It's really one of the lowest points of the film, and it's this sunrise. Normally, sunrises are very beautiful. It's the start of a new day, but for this one, we wanted an angry sunrise. It was just this beautiful tone of red that was so dramatic for me. I think that was
Interesting, right? How suddenly sunrise will become an angry sunrise because he is not happy because the house was burned. Is it cool, Aditya?
Yes, sir. It's very nice.
Because the choice of color is so critical to the storytelling process, it's really important that we understand the science of the choosing of those colors. The first thing to realize about color is that color is really made up of light. Light comprises different wavelengths of energy, and when that energy comes through our pupil onto our retina inside our eye, it becomes nerve impulses, signals, and eventually
See, suddenly it goes into science from physics.
gets processed by the brain. So the light is out in the real world. The color only really exists inside your.
So all these things, if you want, you can create using Scratch. And you can choose these colors.
Brain when you perceive it. In the rest of this lesson, we're going to dive more into the science and perception of color. Let's go.
Okay, I encourage you to learn on your own. So it's very exciting.
what do I
Okay, so that's about color. Now let's learn about, we'll go back to the Phet only. Interesting. Then let me get into bending of light.
Sir, that's also known as refraction, right?
Yeah, let's figure out. Okay. Now let's start with prism and then come back to bending of light. Let me take the classical prism. Now let me switch on the light. It is bending. Okay. Now I wanted white light. Now we will bend it differently. Let me bring one more prism so that I can see it, the light moving up. Okay. So is it realistic?
Yes, sir.
Interesting, right? How we can suddenly simulate rainbow. I can even bend the source. Yeah, this is better. Yeah, this is good. So now you can see clearly the light. Each light is bending by different angle. It is because the wavelength of each light, each spectrum, what we call, is different. Okay, so this is about, then let's replace this prism with something else. Let's replace with what happens if I bring a block.
It
What
passes
happened?
in the same direction.
Yeah, suddenly look at it. I could have got this, I could have got another prism, make it like this, make it, let's see. I made it like another shape. I combined two prism and something else happened.
Rhombus.
Rhombus happened. But what happened to the rainbow? Rainbow vanished. Right? Suddenly,
Yes.
the same prism, it vanished the rainbow because I introduced one more prism. So like this, you can experiment. Okay, I don't take anything on the on its face. And good part, this is also free, and all of this you can also access. And it works on your mobile phone also. It doesn't need, because it's HTML. It works on all softwares. So this is interesting. Any idea, Aditya, what happened to the light? For example, if I remove one, still it gives me rainbow. If
I guess because you use two prisms, it only bends the light because. Sir, I have no idea.
yes, no. Anyway, you know the science now, because I'm not removing any color here. Color was there. White has all the color, but as soon as I bring another prism, which is exactly the same, right? There's no. I brought the same prism and it killed it. Why did it kill the beautiful colors? Anybody else want to take a guess?
Sir, can I guess, sir?
Let's wait for one more minute. Ambika, can you guess?
So by using the one prism, the light will be bent.
Ah.
If we use the another prism, the bent light will be on same. I think.
Yeah, Shobha, what's your guess? Shobha, you can unmute, Shobha. I cannot unmute, only you can unmute, or you can type in the chat window your answers. Okay, Sudarshan, what's your guess?
Sir, guess is that the first prism bends it in such a way that the white light splits, but the second prism from refraction it will change the angle, so that is not enough to split the white light. This is the guess.
You're right. Actually, second one nullifies it. That's the word. Whatever bend this fellow had done, it does the reverse. As you can see, almost light is going parallel. Technically, no bend. Whatever bend happened, I bent it again. Like, let's take this wire, right? You can see wire in my camera. I bend it, Another prism came and bent it again. So light, unlike any metal or plastic, it doesn't mind how many times you bend. You bend it 1 million times, it will keep bending. Right? No loss. There is no loss. You are not losing intensity. You bent it, then you straightened it again. That's all it happened. That means light has to be bent enough for us to see the color. That is the moral of the story. And you can bend it at any time. See, suddenly it appears here. I brought it again at the somewhere at the below. Even though it is, I have two prisms I'm using, but suddenly I see the colors. Interesting, no? Even if I change the angle, you can see I'm bringing there only, but still I'm not losing. So I have to bend it enough so that it is away by enough distance so that our normal human eye can make it. Again, you have to see our normal human eye is also another lens. Okay, if I use some other microscope or something, probably even here also I can see it, or even without this also I can see it, because our normal eye also has a limitation, no? So like this, you also start questioning why it is bending and why it is not why it is nullifying. So then you will get the answer. Now let's forget about what is this shape. Why can't this do the same magic? Any idea, Sudarshan? Why the circular sphere is not splitting it?
Sir, I think a particular angle, some critical angle is not, the sphere doesn't allow that.
Yeah,
That's
let's
all
see
I
what
think.
Toyota people say. Arun Kumar, go ahead.
Yes, sir. I think it doesn't have any sides or corners.
Actually, you can see whatever bend which is happening first, it is getting nullified. Yes, you are right. It needs that angle. Thank you. Now let me get somebody else also wants to speak. Okay, then now let me bring in convex. Again, yeah, this is also doing a bit. At the edge, you can see. Now I will bring concave. Yeah, this is doing a lot of magic. It's also acting like prism. Finally, whatever you use, you have to bend it differently. Bend different color in a different way so that you will see it. So that they will stay quite distance apart. Then there are a lot of words to basically overwhelm you. Aditya, for you. What is diffraction and what is refraction and what is reflection?
So reflection is when the light bounces on some surface and it goes back upwards anywhere, and refraction is when it passes through and gives a little bend.
Then there's another word, diffraction. D starts with D for doll.
I haven't learned that yet.
Okay. You can Google and learn.
But I will try. Yes, I will read it in my textbook.
Sure. And there's also a popular advice you get: don't stare at light during sun. What is it?
Yeah.
Eclipse. Or eclipse. Why is that?
Because it can damage our eyes.
Suddenly, why sun becomes dangerous on the eclipse day? Question, no? Because distance did not change. Sun is there, moon is there, earth is there. We are at the same millions of kilometers away. But suddenly the light on the eclipse day became dangerous. You have a question, no? Ask your teacher. Ask Google. Okay, now let's learn about bending of light. Reflection, refraction, all those things you will learn. Okay. Now, there is air on the top and water below. If I make water also above, suddenly Who is that? Can I show project related to light? Yes, you can. Just give me a second. Let me finish this one. So now suddenly, why I make above AF, suddenly some portion is getting reflected, some is bending, refraction. So suddenly if I make water also above, why it is not bending anymore? Any idea?
So because here water acts like a glass, and from the water it may reflect.
Yeah. Anyway, it's technically there's no water. It's everything is inside water, right? There are no. I made both same. Now I will make the bottom glass. So, which is denser? Is denser? Glass is denser.
Glass.
Glass is denser. So, what is the denser? It's called index of
Refraction.
Yes, you can see it's 1.5 for glass, 1.33 for water. That's why it is bending below. Now I reverse it. I make glass on the top. I make water below. Now the bending reversed. Instead of bending down, it bend up towards the denser medium. My angle of incidence is still 60 degree. Now let's measure how much we are losing intensity. 80% is going through, 0.19% is reflected, getting reflected. Now let's change the angle at some point, 100% is getting reflected. Interesting, right? Both the medium is the same. I have glass on the top, water below, 100% getting reflected at one angle. What is this angle called? Those of you who are in 10th standard, you should have studied by this time. What is this angle now?
Angle, angle of reflection, right?
No. This particular angle, whichever you are seeing around 55 degree. Let me, now you can see at one point, at 60 degree, it's still 20% getting reflected. I start increasing to towards 65. Somewhere in between, now 64 degree. At 64 degree, 100% reflection is happening. All of you use, do you know how you get your internet? Through fiber optic cable, right?
Yes, sir.
So in fiber optic cable, how does the light travel?
Through the reflections.
Same thing, what I am showing you here. Only if the light is sent at this angle, you will get your internet at 100% bandwidth. If the light goes like this, that means you are losing your signal. So they will ensure that light goes in this angle, minimum 64 degree, and anything, even they can go up to this. There is no issue. Here also there is no loss. Up to 90 degree, there is no issue. Only below, anyway, it is not allowing me to go below. So 64 degree to 90 degree you can do, but if you increase it further, you will start losing. This is called total internal reflection. Have you heard this term?
Yes, sir.
So now you can see, yeah, you will see a study, don't worry. Before 10th standard, they will teach you this in physics. So 100% is getting reflected. Then what they will do, it's a tube actually. What you are seeing inside that fiber, this is what's happening. So then it will, then there's a glass, means a denser medium on the other side, then it gets reflected back. So like this, it goes through various reflection and you're not losing anything. So it becomes interesting. Now let's make it air on the top, water below. Again, same thing repeats. Okay. So now you can experiment. Now what am I doing? Index of reflection, I'm changing. So you can see how it goes left and right. Here also you can see. Okay. So like this you can experiment. Then this prism we saw. Then here what do we get? Anyway, what is this? Let me bring that. Where is that? What is this and what is this? Is it the real light or is it the real light?
Sir, I guess both are the real light.
This is real light actually. Our eyes will not see it. It is, what is a wave? What is a wave? When you throw a stone into water, still water, whatever you see, that's the wave. How does sound travel?
Through waves.
Yeah, waves. How does light travel? Through waves.
Wavelengths.
Yeah, that's why it's called wavelength. Okay, so you can Google and find out what is the wavelength. And what is the difference between wavelength of sound versus light? Why light travels faster than sound? Okay, you can find out all the answers. What is this happening now?
Frequency.
Like no, actually it is magnifying and showing you the wave. Interesting, right?
Sir, I guess if I was in 10th standard, I would be able to answer everything.
No problem. Now it will make you curious so that when your teacher covers this, you know you already seen it somewhere.
Yes.
Look at this, how interesting they have made. You can see waves of two rays. One is reflected ray, one is the original ray. Then actually the distance between two vertical lines we are seeing in this smaller window, it is wavelength. Okay, it's magnifying and showing you how the light wave is traveling. Very nice. You can see wavelength decreasing, no? Let me make it only one wave. You can see whose wavelength is less, whose wavelength is more.
So blue's wavelength is more.
Blue is less or more? This has become shorter, no?
Yes, sir. Sorry.
This is short. The wavelength of blue is smaller than wavelength of red.
Right.
So this is called in rainbow. It's also called infrared.
Yes, the light beyond red color.
That is dangerous actually.
Yeah.
That is the what it will kill your.
It can burn our retina.
That's why.
That is the same answer for eclipse. Now I remember just now.
Yes. Smart boy. You know how to connect the dots. Okay. Now you know what is the wavelength, which is dangerous, which is not. Okay. And you all know about solar energy. There, do we need heat or light to convert solar light into energy? Electricity.
Light. Because of light, we get heat.
No, both are different, no?
But sir, if we concentrated light, we can get heat.
Yeah, I agree. But for that, you need that infrared component. Okay. So, anyway, suddenly light became so much interesting, right? Where all did we go? From Pixar animation, now we are discussing about eclipse. Yet, there is a lot to discover. Right? Still, we don't know what is diffraction, D. It bends around the corner. You can find out why it bends around the corner. ठीक है? Already we are at 12 o'clock. Let's get back to our Python. Let me share. I see Ganesh. Hi, Ganesh. Thanks for joining.
Hi, sir.
So let me go back to my Python. Before this, I wanted to, yeah, let me go there and come back. Okay, let me see what else I have here. Now let me switch to another Raspberry Pi. I'm running two Raspberry Pis here. What is Raspberry Pi? Anybody? Guesses?
Sir, can you ask again?
What is the Raspberry Pi?
Sir, it's sort of a like little computer
Yeah.
where we can code and run. We can also make a computer from it.
Yeah, I will just show you one of them. So just you can see my video if you want to pin my video. So here is Raspberry Pi looks like, and inside this box you will get this. So this is a full-fledged computer. Now what on the other screen which I'm presenting, it is actually one of this which I'm playing. I'll show you what I'm playing. And this is the cover. Let me bring the cover. So this motherboard goes into this. So this is a full-fledged computer, and it costs only 3,000 rupees in Bangalore. Now let's see how interesting this has become. Now I will switch to my presentation screen. Now you can see I'm going to play this music. As you can see, this is Game of Thrones music. It has been coded here using a program called Sonic Pi. So let me switch on the speaker. Give me a second. It's coming up. Just give me a second. You should be able to listen to the music now once I click this play. Are you able to hear?
No, sir, it's breaking.
Yeah.
The voice.
Okay, okay. Breaking is fine because of the latency, but you're able to hear, right? Some Game of Thrones sounding music is coming. Let me bring in familiar Twinkle Twinkle Little Star. Don't worry about coding. I will teach you how to code this. Let me just play this. Are you able to hear Twinkle Twinkle?
Yes, sir.
Okay, I will share this code. Actually, I had shared this code yesterday. I will bring that up again, where and how to find all these nice codes. Okay, then this is just about the same key. Let me see full release. Yeah, this is the full release. Last time we played in Scratch. Now we can see same thing, which is coded in Sonic Pi. Interestingly, now suddenly you see coding of full release, how simple this becomes. Yeah, all the code will be in same line, one line. This one is one stanza. Don't worry, I will tell you, or I will send you one user manual. Step by step, they have given how to make this music. So this represents each piano key. Let me just play this. I know volume is a bit low, but you are able to hear, right?
Yes, sir, but very little.
Yeah, don't worry. I will share this code with you. Now let me bring up what the source code and the help document which I had shared. So I had shared in the Google Drive. Let me bring the same Google Drive which I had shared. So you're able to see my screen, right? So this is what I had shared. Now Game of Thrones, anyway, code is here only. The Game of Thrones code is here. So you can download if you want, if you have Sonic Pi installed. Now let me go to Sonic Pi and show you.
Sir, from where do we have? Where can we install Sonic?
Yeah, I'm going to show you. Yeah, I will show you. So Sonic Pi site is here, sonic-pi.net. I'll put it in the chat window also. So here is the site, and at the bottom, if you go, here it is where they have given how to install. Sonic introduction. Yeah, here it is. Download 32-bit Raspberry Pi OS or terminal installation. Where is that? Here it is. If you are using Windows, use this middle one. Windows 10 on 11 left side. Okay. MSI, all the three will work. Got it, Aditya?
Okay, sir. Thank you.
Yeah. Now let me play some simple music here. It starts with bells. Now it starts with scales and chords. You can see that's all the code. Just 4 lines of code. Then bikes is not fun. Rhythm is okay. can listen with your headphone on. It produces all drums and all musics. You can create ocean waves also. Then you can break beats. So like an orchestra, right? This is fun, no, Aditya? Are you able to hear the full orchestra?
I am able to, but it is very little. Sir, if you have an external speaker, then it would be good.
Yeah, don't worry. Let me see if the external speaker helps. Let me switch to external speaker now. Did it? Were you able to hear? It was very loud in my room. Okay. Probably I encourage you to play in your machine. No, the link is the same, sonic-pi.net. And there are play buttons. It will play. You don't need any installation. It will play directly if you click any of these. Okay. Drum music is really awesome. Suddenly you will see this all, whatever you code and create, it's your music. You are not copying anybody's music. So that becomes your copyright. You can use it in your videos. You can use it in your presentations. Okay. Suddenly you can become Ya Rahmans of the world. Okay. So you can see how exciting is. Let me play the Game of Thrones. So all these codes are there in the drive, which I had shared. I can share it again. Okay, so I will put it in the chat window as well. Give me a second. So this is, I have made it available to public. You don't need any extra access. So if you click, it opens. Can one of you click and tell me if you are able to open it? In the chat window, I have given the link, drive link. So you have Sonic Pi, that PDF has your step-by-step guide, see, including Twinkle Twinkle Little Star. It starts with, okay, so this is a very step-by-step guide with this PDF. Then, like the rest of them are the code. So very interesting. There is a code even for Janaganamana, our national anthem. You can play that and you can learn from that. There is one at level 0 that's very simple. Level 1 is slightly complicated one. This is slightly complex one. And whereas this one is very easy, level 0. Okay, I think we have come to close to 12:30 now. So, yeah, what else do you want to know today? Now that we have spent close to 1.5 hours.
Sir, can I show my project related to light?
Sure, please go ahead. I will make you a presenter. Give me a second. Yeah, go ahead, Aditya.
Okay, sir. So this is the project I made, like the RGB background means I took a background from Google and I did it like I coded it to do RGB. Means if you can pay
Yeah.
attention closely, you can see it changing the color. It's like
Show the
breathing
code.
LEDs.
Let me see the code. Show the code.
It's actually very
Yeah, now I can
simple.
see it. Show the code. Yeah, let's see. Can you maximize, zoom the code? Zoom it so that we can see it. Change color effect by color. What is color?
Color is the
You are setting
variable which
color
I
to 1.
create. Yes.
Very nice.
It's
So this trigger is when, yeah, let's see if there are any questions. So anybody has any question? Anisha, can you tell what's happening here?
Yes, so 1 second. I can't really see a screen. It's a little black for me. It's still loading for me.
Sure. Anybody
Okay,
else
yes.
would like? Yeah, go ahead.
So my screen is a little blurry, but I can see most of it. So I'll just
No,
try to
see
do.
the code. In code, he
Yes.
has written very simple code. Can
So
you tell
he's
us?
written that when the start button is clicked and he's put a forever loop. So in that forever loop, we said that wait 0.2 seconds. So that's very, very, very less than even 1 second. And so after 0.2 seconds, change the color and change color effect by color. That means change the color and set color to 1.
Yeah. So what's exactly is happening?
So he's made like a forever loop that after 2 seconds, 0.2 seconds, the color should change and that color should stay.
Yeah. Now let's see. Plate. Press the green flag. Aditya. Now we can see the impact slowly changing. Feels as if the war is happening, right? As if somebody is changing the light.
Yes, sir.
Suddenly now there's a green, more green, slowly turning more grayish. Yeah. Now violet is coming in. Blackish. Nice. So this is how the VFX movies are made, right, Aditya?
Yes, sir.
Visual
Sir,
effects.
can I also show another project related to this? So this is like the pattern maker. Just let me remove the sound. Okay. So if I press the green flag, then I can control these balls with my arrow keys. And they also use the RGB like to make patterns.
Now go back. Yeah, go to the code. Let's see how you are creating the pattern.
Yes. So I use the pen means through this thing like the pen I choose an extension, and then with pen I created.
Now I'm curious
this.
to know how you are creating the shape. Yeah, how the circular shape is coming.
Means, sir, I did not understand.
How it is coming in a circular shape. It's coming in a concentric circular shape. I just want to see how that is getting
because
created.
of the angle. Because of the angle. Means I took the angle and I did it to the 45 degrees. Like I told the means I commanded it to turn 45 degrees. That's why.
Yeah. So it is 45 degrees every time you click, right?
Yes. And I'm only like
So what is that trigger? When I start a clone as a clone, means you're cloning in a loop, right?
Yes, cloning the balls.
Show me the
And
loop.
then when I press the up arrow key, the ball moves 45 degree and it move 5 steps ahead. That's why it creates this circular shape.
No, actually, trigger is, where is the trigger? I didn't see any loop here. Show that where you are calling when up arrow is pressed. Where is that command?
Here.
No, because first this should be, clone should be called. How does the clone is getting triggered? Show me the other piece of code which is on the left side. Now drag your code, or you can share the code in your chat window so that I will also see and I can explain.
Okay. Because I'm not understanding your question.
Yeah, just share the code URL of this. Is it shared?
Yes.
Yeah, 1 second. Let me, 1 second. Okay, I saw that. On the left side code, go to the ball only. Yeah, on the left side code, there is you are looping it 10 times.
Yes.
Okay, the 10 times
Yes,
you are calling the clone. So 10 times your right loop is being called.
Yes, sir.
Okay, so that's what doing magic. Very nice.
Yes.
Nice imagination. Nice use of colors.
Also,
Color
after
is very beautiful.
you are done with, yes, it looks really satisfying.
Yeah.
Also, if we are done with your pattern, then we can change the background, like sort of a painting.
Yeah, nice. Yeah, anybody has any questions? Arun Kumar sir, ನಿಮ್ಮ ಮಗನ ಹೆಸರೇನು?
My name is Utkarsh.
What's your name?
Utkarsh, sir.
Utkarsh. You are in which standard?
6th, sir.
6th standard. Did you like today's session?
Yes, sir.
So that's nice. Which portion you liked?
I like about that Python and that about color.
Very nice. Are you also learning Python?
Yes, sir.
At such a young age, at 6th standard. Who is teaching you Python?
Yes, no, sir. I'm not learning it.
Oh, you want to learn? Do you want to learn Python?
Yes, sir.
Why Python?
Sir, because I like it. Today I got to know what is it.
Okay. That's nice. So you're not being overwhelmed with Java, C, a lot of other things, no?
Yes, sir.
Yes, stick to Python. Even though others are learning Java, that's okay. Let them learn. All are same. Finally, you have to learn one thing perfectly. What, Aditya?
Yes, sir. That's right. That's the
So,
same
Aditya,
thing I
you're
did
also
out scratch.
Yeah. So Scratch, Python. Learn one thing perfectly. You can learn Scratch and Python together. No issue. So that you will go into depth.
Yes.
Okay then. If there are any questions, I can answer. Yeah, thanks.
So
Aditya.
till now I have learned
Any other questions?
Python.
Go ahead.
So till now I've learned about Python, like numericals, like int means int and all.
Very good. Yeah, keep learning and do some interesting project and let us know. Okay. So are there any other questions? So we will close the session today by answering any pending questions. Sinchana, did you like today's session? Sinchana, Chandana.
Yes, sir.
Which portion did you like?
Sir, first one.
Tell me what is first one, no? We did a lot of firsts.
Animation.
Very good. So Pallavi, what did you feel about the way we engaged the audience today?
Yeah, so that was really great. So I think the kids got to learn a lot of things along with the coding, like you taught us about the reflection, all the science topics. So that was really a good one. The simulation, the one they used to demonstrate the prism thing, blue. So that was really great. Like using this visual based learning, the kids will be able to get to know the things very faster, and it will remind for the topics will be very clear for them.
Yeah, thanks. And also you would have seen whatever I use today, everything is open source.
Yeah.
It's free
Yeah,
and
I
it works
think
on all.
the kids can also avail those resources and they can go through it.
Yeah, and it works on all platform, whether they are using mobile phone, laptop, Windows, Linux, or Mac. Doesn't matter. It works on all. For example, today I used Windows as well as Linux. Raspberry Pi is running on Linux. I'm using Mac. I'm using iMac, so it is Mac OS. So you did not feel any difference. I was switching between the OS seamlessly.
Yeah. So it's a
So
platform independent kind of a thing. So that is very handful to us. Yeah.
Yeah. So that's important because students, especially the young learners, should not get overwhelmed by technical details.
Yeah.
They
That's
should just
true.
enjoy and they should start actually, whenever they are learning, they should learn with a purpose. For example, today they learn animation, Scratch. It can also keep creating games after games, but it is not, it won't help in long run. So quickly, we have to take them. Next time, probably I will show how to even teach Kannada using Scratch. We use even teach grammar. Savarna Dirgha Sandhita, Purusha Samasa and all we teach using Scratch.
Oh, that's interesting.
Yeah. Then I didn't show about how to create sentences in English. You can do Scratch by just dragging and dropping different blocks. So primary school kids can use that. The middle school and high school kids can create that animation and pass it on to primary school so that primary school can learn the grammar portion.
Yeah, like usually through projects, the kids will be like interested more to learn about it rather than just reading the things in the textbook.
Yeah.
This is really a good approach.
True. And today we had students starting from 5th standard till 10th standard. And interestingly, the project which 8th or 9th standards are doing, it will be definitely be helpful by their own colleagues. For example, the heart simulation. It was done by an 8th standard student of Vijaya High School. And she actually, in the WhatsApp, I will share it with you. She has done full-fledged module, including quizzes in between. She's talking about what is heart, what is different arteries and how it helps, all those things. So like this, you can even encourage students to create multimedia animations using Scratch. Everything is free. And if you give that as a homework to your students, so one class student can create animations for their entire all the chapters.
Yeah, that's true. Yeah, it's a really a good idea. We'll definitely implement that.
And now after this, we should also start focusing on enabling teachers. So otherwise, teachers will be left behind. No, these students will be far ahead, both in terms of technology and how they are using technology.
Yeah, sir. I agree with that.
Imagine if the Phet animation with the light, which I showed you today, bending of light, etc. If the teacher starts using that to teach physics in the classroom.
Yeah, that was quite interesting. Like, usually if you just see the textbook and if you imagine that, it will be quite difficult for us to know like how the things work there, especially the light rays, how it passes through the lens and stuff. So through that simulation, it was really helpful. Like we'll
Yeah.
be able to get the concept very quickly.
So if we enable teacher, the advantage is now
Oh.
it will be impossible for me to come and teach all your students. So if a teacher is enabled, then the teacher can influence thousands of their students year after year.
Yeah.
This animation, can you believe it was created 6 years ago?
Oh.
Created by a Nobel laureate called Carl Wyman, and none of us know about it. Now that all of you know about it, please spread it in your network.
Yeah. We do involve that in our curriculum as well, especially
Now,
those simulations. Those were really interesting.
and they have created about 400 simulation, and it's in Kannada. Today I showed only English version.
Oh, that's great. Yeah, the Kannada one will also be helpful because most of the students are from the Kannada medium. So we actually, we try to search the things in YouTube, especially the general topics. We won't find videos, that explains in Kannada. So it will be like quite hard for us to, make them visualize like how it works there.
Yeah, ask us. Don't try just in YouTube. We know where they are.
Yeah, sure.
Very soon it will
These
all come.
resources will be very helpful.
Yeah, very soon it will all come in Infosys Springboard platform.
Oh.
Okay. Have you
That's a
heard about
great
it?
one. Yeah, sir. I have heard about it.
So both you can see Sudarshan and me wearing Infosys Springboard t-shirts. So we are part of the core team who is taking it, and also Sandy who is there.
Yeah, that's a great initiative from Infosys.
So now
that
very
would help
soon
a lot of schools.
Yeah. Now whatever I did today, how useful it will be if everything is available on Springboard, right?
Yeah, so we have not gone through it. We'll definitely go through all these topics and courses.
Yeah, it's already made available. So in another 2-3 weeks, we will open it up to the public.
Okay.
So all your students, your teachers can start using it. This will be a single stop shop. You need not to go and search in YouTube.
Yeah, we'll definitely make use of it. This is a great opportunity.
Thanks, Oliver. Yeah, thanks, Reyes. I hope you also liked your experience. Okay. So thank you all, and have a wonderful Sunday, and see you next week.
Thank you, sir.
Thank you so much, sir.
Thank you,
so
sir.
much.
Bye, sir. Unmuted.
Thank you,
you,
sir. Bye, sir. Thank you,
Bye-bye.
sir. Bye, sir. Thank you, sir.
Thanks. Bye-bye.
Bye, sir. Thank you.
Good to see all of you in the
Thank you.
school.
Thank you. That was a wonderful session, though.
Thanks, Valerie.
Yeah, have a good Sunday. Bye.
Bye-bye.